welcome to the today's topic. Our today's topic is basic classification model, problems on that. I am Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So basically now we are covering the problems. So today I'll take the problem related to classification. So here two of the methods I am taking for classification. So first method is classification using decision tree. In that I am using the Guinea Index. So there are two types of decision tree splits are there. So one is information gain, second is Guinea Index. And I'll tell you about one example and solution of that. And second is classification using naive Bayes. And on the basis of that one example I'll take and I'll tell the solution for that. So first I'll tell you the basic things about the classification using decision tree. So decision tree algorithm falls under the category of supervised learning. So basically here we are providing the training, we can say training sets, and then the machine is going to be learned. So that will be the supervised learning. So the decision tree is the structure. It is in the form of tree structure representation to solve the problem, in which each of the leaf node represents to a class level, and other attributes will be representing the internal nodes of that particular tree. So in decision tree, the major challenge will be is to identify of the attribute of the root node. So how to identify the which of the class level is as a root node. So that will be the most challenging task to do. So this process is while we are going to select these are the attribute, these of the class levels. So that process is called as a attribute selection. So that procedure is very lengthy. So we have two popular attribute selection measures. So first is information gain, second is Guinea Index. So information gain, what is information gain on that? Information gain is used to determine which feature, or we can say attribute, gives the maximum information about the class. So about the class level, which of the attribute is giving the highest value, that will be the root node, that will be taken as a root node if their information gain is high. So information gain will be based on the concept of entropy. Entropy will be used, which is the degree of uncertainty, impurity, or we can say disorder. So these are three, same thing is there. We can call it as any other name. So information gains is going to aims to reduce the level of entropy. So here the less of the entropy we will get, the much is that will be the root node. So that attribute will be the root node. So the information gain aims to reduce the level of entropy starting from the root node to the leaf node. So for each of the node, we have to calculate the entropy for that while we are using the information gain measure for attribute selection. So entropy is not referred, we are not going to prefer that because of the log function. So in the entropy, we are using the log functions because we will not use that particularly majorly because it increases the computational complexity. So more of the computational numericals we have to do. Now second attribute selection measure is Guinea Index. So Guinea Index, we can say Guinea impurity, measures the degree of probability of a attribute, a particular variable, being wrongly classified when it is randomly chosen or randomly selected. So if all elements belong to a single class, then it will be called as a pure Guinea Index. The degree of Guinea Index, that will be vary in between the 0 to 1. In the between 0 to 1, it will be the entropy will be Guinea Index will be there. Where 0 is the all elements belong to the certain class. are, we can say, if there exists only one type of class, and here 1 denotes to the elements that are randomly distributed across the various classes. Okay, so Guinea index of 0.5, if there will be the Guinea index as a 0.5. So we have taken 0 and 1. So how we are denoting 0 and what is 1 for the Guinea index? What is 1 0 for the Guinea index? Now, if Guinea index is 0.5, so that is donating the equally distributed element in the some classes, right? So the formula is there to calculate the Guinea index. That is, Guinea is equal to 1 minus summation of n to I is equal to 1 and pi square. So P is the probability here, where P is the probability of an object which is taken, which is classified to a particular class. Now, for today's example, we are taking the Guinea index measure. So problem is there. Problem is that let's consider the data set in the image below, and we are going to draw the decision tree. So on the basis of that Guinea index, we are going to draw a decision tree. So now this is a table that is having the 4 class levels A, B, C, D, and E is the class level that is classify it as a positive and negative. That is a class level that is classify it as a positive and negative. These are the four classes are there. So in that there are some values are there. There are 16 values, 16 records of that is having the positive and negative classes, right? So in the above data set, there are 5 attributes, from which attribute is the predicting the feature which contains 2 positive and negative classes. 2 of the classes are there, positive and negative. Now in the data set, we have an equal proportion of both of the classes. So half of the values are positive and half of the records are negative. So in Guinea index, we have to choose the some random value. On the basis of that, we are going to categorize the each of the attribute. So these values for this database can be, we are taking it as a 4 features are there, A, B, C, D, right? And we can say less than equal to 5, like this. The one table is there that is having the random values for each of the features. 4 of the features are there, A, B, C, D. Now we have to calculate the Guinea index for the each of the feature. So for feature A, we have to calculate the Guinea index corresponding to the class level, positive and negative. Now for calculating the Guinea index for the past trend, what was the past trend were there? Calculating the Guinea index for value A, variable A. So if value is greater than or equal to 5 by 12, so attribute A will be the greater than or equal to 5, and class will be the positive. So for positive class, there are 3 instances are there. So we have to calculate the how many times positive has been occurred when attribute is greater than and equal to 5. So that has been occurred for 3 times, and total positive classes are there 4. So that will be divided by 3 by 4, right? Again we have to take it for negative class. So for negative class, attribute is same, it will be A will be greater than or equal to 5, and class will be the negative, and there are 7 instances are there, and there are total instances are 12. Total negative instances is there in 12. So that will be 7 by 12, right? Now we have to check the Guinea index for that. So Guinea index will be for 5, 7. Guinea of 5, 7 is equal to, the formula was that it's 1 minus pi is square, pi of square. So that was a probability. So here two of the attributes are there, right? So one attribute is 5 and the other is 7. So here 1 minus we can say 5 by 12. So first attribute is 5. So 5 by 12 and square minus 7 by 12. So other is 7 by 12. So here 5 by sorry, here this is by mistake. So that will be the 5 by 12. So the first instance was for positive classes. So that has been occurred 5 times positive, and that will be the total classes of that there is 12, and for negative 7 by 12. So now we will calculate 5 by 12 Guinea index for that. 1 minus 5 by 12 square minus 7 by 12 whole square, and that will be 1 minus something. The calculation we will take for that, and that will be come as a 4.4860. So the Guinea index for 5 and 7 will be 0.4860. 4860, right? So now we will see what is the Guinea index for other values. So if we will take the value that is greater than or equal to 5, 5,4, so attribute will be the A will be the greater than or equal to 5, and class will be positive. So for class positive, there will be the 3 instances that will be total positive instances is there for 5 by 4, that is 4 times. So 3 by 4. Like that, negative will be 1 by 4. So now Guinea index will be for that 1 minus 3 by 4 whole square minus plus 1 by 4 whole square, and that will be deducted from minus 1 minus. So now it has been come as a 0.375 something, right? So now by adding these of the two weights, and we are going to sum that each of the Guinea indexes. So Guinea of target of A. So now the Guinea of target A will be 12 by 16 into 0.486. So what is 12 here? So total how many positive classes are there? Total, for not corresponding to this value, not corresponding to this value. So what is total positive classes there? 12 by 16. So total is 16 and positive is 12. 12 by 16 into what is the value for this particular 5 colon 12 value. So that was 4.4860. That will be plus, and 4 by 16, that is negative classes, divided by total into 0.375. So total Guinea index for the target A will be there for value A 0.45825. So we can also write it as a 0.46, right? So that was the Guinea index for value A. Now we will calculate same Guinea index for the B value. So that will be the two of the values we will take, 12 and 4, sorry. So now we will calculate the attribute for the positive and negative. So what will be the positive instances for the 12 value? So that will be the 8 times positive has been occurred, and by 12 negative 4 by 12. So that will be the calculation came out as a 0.4460. For 3 colon 4, that has been come out 0 by 4 and 4 by 4. So that will become as a 1. That is 1. So now we are going to add the weight and sum each of the Guinea indexes. So we have to add each of the Guinea index as a sum. So Guinea of target comma B will be 12 by 16 into 0.446 plus 0 by 16 into 0 into 0. So now it has been come as a 0.3345, right? So that was that is the Guinea index for the B value. Now we are going to use the same approach. We can calculate the Guinea index for other points, that is the value is C and D. So that we will get as a, for C we will get as a Guinea index as C is equal to 0.2. The same formula we will take it as earlier we have taken for two variables. For D value we will get the Guinea index as a 0.273. So now from the these of the calculation, from the these particular 4 of the calculation, we have got the Guinea indexes for each of the value. So for the above table we observe that C has the lowest Guinea index. So in that is for A 0.4582, that is 0.46, 3345.334, for C 0.2, and for D 0.273. So minimum is, the minimum Guinea index is for C, that is 0.2. So this is the lowest Guinea index, and hence it will be chosen as the root node for the decision tree, while we are going to depict a decision tree for that. So the index, from this table we can see the Guinea index attribute features. So here attributes are there, A, B, C, D, and Guinea indexes is there. So that is for simplicity of that calculations. We can directly see here 0.2 is a lowest Guinea index. So the decision tree will be depicted like this. The decision tree for the above data set will be the C will be the root node. That is a root node, that is null. That will be the root node. Again, on the basis of Guinea indexes, again we will calculate the Guinea index. From that we have to remove the Guinea index. We can say the class levels for the other levels. So there were positive and negative. So we will discard from that negative. So we will take it as a positive, and again we will calculate. So now again we will take we will got as a D is the lowest Guinea index. So like this, again we will get the B as a lowest Guinea index. So a decision tree would be a great way to represent the data, and we can say like this, because it takes into the account for all the possible paths. So how many possible paths can be there? In the decision tree we can see one by one. That can lead to a final decision for the end users, for the decision makers. So by that decision tree like structure, we can have the much clear picture of the all the related attribute and values. So this was the decision tree from that particular five features that were A, B, C, D, and E was the class levels. So that was positive and negative. So I am again repeating what we have to do, how we are going to represent that decision tree. So we will repeat the same procedure to determine the subnodes and branches for the decision tree, as we have got the C as a minimum Guinea index, right? So we will calculate the Guinea index for the positive branches for the C as follows. So now we will take the positive classes for the C. Now, so that was so we will get the D as a splitting node, and we will repeat the same procedure till to determine the subnodes, or we can say branches of the next decision tree. What is the next node in that decision tree? While C is the root node and D is the child node, right? Again the Guinea index, and we will get the next node as a B. So B we will get. So all the attributes has been covered from that features. So decision tree has been completed here. So like this, again and again we have to do the same procedure, but this is the very we can say easy procedure to get the result quickly and fastly, as it is shown is a graphical representation. So Guinea index, unlike we can say information gain is also there, it is computationally intensive and it does not involve the logarithmic. So here in that we are not using the log function used to calculate the entropy in information gain. So this is why Guinea index will be preferred for over the information gain. Okay, so another classification method problem we will take for the naive Bayes. So classification using naive Bayes. So first we will take the basics of that. What is the basics of naive Bayes? So it is a basically classification technique based on the Bayes theorem. So that is basically based on the Bayes theorem related to the probability which with an assumption of independence among the predictors, right? Now we will take one example for classification using naive Bayes. So what is naive Bayes basics? So a naive Bayes is nothing but that is a technique, that is a classifier that is going to assume that a presence of particular feature in a class. So that is unrelated to the presence of any other feature, right? So it is a classification technique basically, and based on the Bayes theorem in probability with an assumption of independence among predictors, right? So for example, a fruit. if we will take a fruit as an example, that may be considered as a apple. So why? If it is red, round and about 3 inch of diameter. So these are the three features that is going to represent that is a apple, that we can say it is a apple. So name bias model is easy to build and particularly useful for very large databases. So the Bayes theorem formula is there. The P C by X is equal to P X by C into PC divided by PX. So here the P is PC by X will be the posterior probability. The PX by C will be the likelihood. The PC will be the class prior probability and PX will be the predictor prior probability. So here where we can see the PC by X is the posterior probability of class, the class and target. So class C and target given the predictor X and attributes. The PC is the prior probability of the given class. Px by C is equal, will be the likelihood, which is the probability of predictor given class. The class is there. And Px will be the prior probability of the predictor. So Bayes theorem provides a way of calculating the posterior probability PC by X from PC, Px and Px by C. So these three we will need while we are going to calculate the PC by X. Now the one problem is there. Suppose you have 1000 fruits. Suppose we are having 1000 fruits which could be either banana, either orange or any other. So that has been featured as banana, orange and other. So one example is there. Suppose we have 1000 fruits is there which could be either banana, orange and other. These are the three features are there. There are three possible classes of the Y variable. We have the data for the following X variable, all the which are binary to 1 or 0. So that will be long, sweet and yellow. Right. So first few rows of the training data set looks like this because that is having the 1000 data set, but 1000 records. So we are having the few records, the fruit, long, sweet and yellow. These are the four we can say features are there. So the record is for orange is 0, 1, 0. These are the other feature values. For banana 101, banana 111, other 110. So like this one training data set is there with us. Now solution will be the, for the sake of computing the probability, let's aggregate the training data to form the counts like table like this. So from that 1000 record we have taken the type long, not long, sweet, not sweet, yellow, not yellow and total. So like this the aggregated table we have taken to apply the name bias formula. So now we are having the type, the class level, long, sweet, not sweet, sweet, not sweet, yellow, not yellow, yellow. So these are the few 6 features are there and total is there. So but on the basis of banana there is 400 values there. So like this we have aggregated all the values in this particular table. So the objective of the classifier is to predict if a given fruit is a banana, a orange or other fruit. So when only we are having the three features, long, sweet and yellow, that are known, that is we are having into the training set, right? So let's say if you are given a fruit that is long, sweet and yellow. So can you predict what fruit it can be? It is. So let's solve the it by the hand by using the naive Bayes formula. So in the step 1, what is the step 1 for naive Bayes classification? So compute the prior probability for each of the classes of fruits. So now we have to calculate the prior probability. Let's compute from the training data. So out of the 1000 records in the training data, we are having the 500 banana records. So 300 orange records, 200 other records. From the aggregated tables we can see. So the respective prior can be the 0.5, 0.3 and 0.2. So let's see how we are taking these three values. So P, y is equal to, if y is equal to banana, yes, banana is there. So the 500 value will be divided by 1000. That is the total value of the records. So 500 divided by 1000, that will be, we came out as a 0.50. So if P, y is equal to orange, that is 300 divided by 1000, that is come out as a 0.30. While P is a y is equal to other, the 200 divided by 1000, that will come as a 0.20. So these are the three prior probability values are there. In the next step, the second step is there, compute the probability of evidence that goes in the dominator. So now that goes in the dominator, what was that? Px. So this is nothing but the product of P of x's of all the x's. What are the all x's are there? Now this is an actually optional step. We can calculate or we cannot. We can understand about that. So because of the denominator, that will be the same for the all of the value. So again and again we don't have to do to all the classes. Denominator will be same. So that will not affect the probability also. So let's see how we are calculating the denominator for that. So Px is equal to ln will be the 500 divided by 1000. So the value came it as a 0.50. P of x is equal to x2 is equal to sweet. So the 650 divided by 1000. So 0.65. Now Px is equal to x3 is equal to yellow. So the point come at the value come out as a 800 divided by 1000, that 0.80. So these are the three denominator we have find from that particular three values. So the three features were there, long, sweet and yellow. So these are the three values we have got as a denominator. So next step is third step, compute the probability of likelihood of evidences. So now we have to calculate the likelihood, that is Px given C. So that goes into the numerator. So in the numerator that was there, we have to multiply it by the other value. So it is the product of conditional probability of the three features. So that can refer to the formula. It says the Px given y is equal to k. So here x is the long, x1 is equal to long and k is the banana. Here that will be the banana, that will be the banana and that will be the long fruit, right? So now we have to calculate the numerator for that. Now this means the probability of the fruit is long given, that is the banana. In the above table we have seen the 500 banana were there, right, in the aggregation table. So out of that 400 will be the long fruit, right? So now P long given banana is equal to 400 divided by 500. So that has been came out as a 0.8 value. So here we have done it for the banana alone. Now the probability of likelihood for banana, P x1 is equal to long given y is equal to banana is equal to 400 divided by 500 is equal to 0.80. Now for P x2 is equal to sweet given y is equal to banana. For that 350 value is there divided by 500. That came out as a value is 0.70. So that is actually for the numerator. Again for the x3 value, that is yellow, Px3 is equal to yellow given y is equal to banana is equal to 450 by 500. So the value came out as a 0.90. So the overall probability of likelihood of evidence for the banana is that will come it as a numerator. So we have to multiply three of the values. So that has first value for x1 is x1 is equal to sweet. So that will be like that. X1 is equal to long. So 0.8 into 0.7 into 0.9. So that will be calculated is a numerator. Now step 4. So in the step 4 we have to substitute all of the three equations into the naive Bayes formula to get the result. The probability of that the fruit is, what is the fruit? So after all the calculation, that it will become as a banana. It is a banana fruit. So P of banana given long comma sweet comma yellow is equal to P of long given banana into P of sweet given banana into P of yellow given banana into P of banana. That will be divided by numerator. What was? P of long, P of sweet, and P of yellow. So the 0.8, 0.7, 0.9 into 0.5. 0.5 will be the P of banana. That will be divided by P of evidence. So that will be equal to 0.252 divided by P of evidence, right? So P of orange, like this, we have to calculate it for the orange and fruit also. So the P of orange given long, comma, sweet, comma, yellow, that will be the 0. So it will come at a 0, out is a 0. Why? Because P of long of orange is equal to 0. So that is came out as a 0. So all will be the 0. So next for the other fruit. So P of other fruit given long, comma, sweet, comma, yellow is equal to 0.8575. So divided by P of evidence. So that is nothing but that is a substitute of all three equations that has been fitted into the Levi bias formula. Now answer will be the banana, because banana is the highest calculations, highest probability it is that among the three of the classes. So here we have got a highest calculation for the banana. So that fruit will be the banana while we are going to classify the three of the classes. So that was all about the problems related to the classification, and we have taken the decision tree as well as the naive bias for that. For today, that was all about. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.